Hi everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is binary tree to CDLL, and CDLL stands for circular doubly linked list, and it is a medium level problem. I know that this video is very late, and that's because I've been traveling since morning. So, and again, I'm not sure if I'll be able to upload the video tomorrow or not. But in any case, I just wanted to discuss this problem because I found this problem very interesting and a perfect example of why you should not overthink about recursion. Right. So there is a very specific reason I wanted to make this video because recursion is very simple and I wanted to explain you this particular part with the help of this problem. Right. So let us understand what the problem says. It says that we have been given a binary tree of n edges. Right. So it's a simple binary tree. We have to convert this binary tree into a circular doubly linked list. Right. And we have to do it in place. That means we cannot create a copy. We cannot create new nodes. We just have to modify those pointers left and right so that we can create a circular doubly linked list. So I hope that you guys understand what is a circular doubly linked list. A simple linked list is like this. Right. So this is a simple linked list. Doubly linked list will be where these edges will be on two sides. Circular will be when the first and last are also connected. Right. So you see there are three conditions. So first of all, it is a linked list. It is a linked list. The second one is it is a doubly linked list. Right. There are edges from left to right and right to right as well. Right to left as well. And the final one is that it is going to be circular. Right. So we have to convert the given binary tree into this kind of circular doubly linked list. And right, there should be some order of the nodes, right? So they have said that the order is going to be in order. So we have to follow in order traverse. So that means if I have a binary node like this, binary tree, right? So if I do the in order traversal of this particular tree, this is going to be the first node, this is going to be the second node, third, fourth, fifth, sixth, and seventh. That means if I convert it into a linked list, circular doubly linked list, there are going to be 7 nodes. So these are 5, 6, and 7. So these are going to be connected like this, and then this, and then this, right? So the connections are going to be like this. This is what we need, and the first one to the last one. So this is our whole requirement, and let us see how we can solve this problem. So let us say for any node, I just want to talk about the current node. This is what is the essence of recursion. You only talk about transitions, right? We talk about transitions and we talk about base case. If you figure out these two things, then you will be able to solve any recursion problem. The thing is, people generally think too much about recursion itself. That is why they confuse. But here we are just going to talk about these two things. So let's say we have this particular node 4, and let's say we have this tree on the left and this tree on the right. So we have a left subtree and we have a right subtree, right? So I need to ask one question. If I am at this current node, what should be the left of this particular node, right? So what comes before 4? It is going to be this particular node 3, right? So that means the rightmost node in my left subtree should come as here, right? The left of this particular node. So this is 1, this is 2, and this is 3. I need the rightmost node, that is this node of my left subtree, right? And that is going to be my left. This is node 3. Now what is going to be my right? My right is similarly going to be the leftmost node of my right subtree, right? So if this is my right subtree on the right, I have this 5, 6, and 7. So here in the right subtree, I want to find the leftmost node, right? So from the left subtree, I find the rightmost node, and from the right subtree, I find the leftmost node. So from each subtree, I am requiring two kinds of information. The first one is the leftmost node, and the second one is the rightmost node. I'm not sure that which node is going to be left subtree of which other node. So for each node in this particular tree, I'm going to return two values, that is the leftmost node and the rightmost node, right? Now once I know this, everything is solved, because for this particular node I can set its left as the rightmost node of the left subtree, and I can set its right as the leftmost node of the right subtree, right? So you just have to solve this problem now. So let's say this particular subtree 1, 2, and 3 is going to return two values, that is its leftmost node and its rightmost node. So it is going to return me a pair 1, 3. Similarly, this particular subtree 5, 6 and 7 is going to return me two values, that is the leftmost node and the rightmost node. So this is going to return me 5 and 7. Now these two nodes, when I get at this particular position, I know that from the leftmost subtree I need the rightmost node, and from the right subtree I need the leftmost node, right? So I am going to form my answer according to this, and 4's left will be 3. Similarly, 3 left will also be 4. I'll have to set it both ways, right? Now similarly, 4's right will be 5 and 5's left will be 4. So this is how I set up my connection in my circular doubly linked list. Now I have set the answer left and right for this particular node. What is this node going to return to its parent, right? It must be returning some value to the parent as well. So that value is going to be the new leftmost node and the new rightmost node, right? So its leftmost node is now 1 and its rightmost node is now 7. So this whole subtree is going to return 1, 7, right? So you see how simple it is. Now there are certain things that we need to understand here. What if there is no left subtree, right? What if there is no left subtree? So when I calculate the answer for this whole node, let's say I have calculated this whole answer and there is no left subtree. So when this particular node is going to return the leftmost and the rightmost node, what value should this node return? Right, now this is a new question, because now it doesn't have any left subtree, so there will be no leftmost node for it, this particular node. So what should we return? Right, for this we can take an example of a tree like this, right? So now if you do the in order traversal of this particular node, then it will be 1, 2 and 3. So you see the leftmost node has become the node itself, right? So if there is no leftmost node, it is going to be the node itself and it is going to return itself as the leftmost node. Similarly, if the tree was opposite, if there was no rightmost node, here it is null pointer. If there is no right subtree and there is no rightmost node, then what is this going to return to its parent? It is going to return itself, because now the in order traversal will be 1, 2 and 3 like this. So for the right subtree, it is going to be the node itself. So basically I am trying to cover different cases. The first and the very important case was this one, what happens in a general case. Now these are some edge cases that you can think of, but even if you don't think, it will automatically come to your mind whenever you are going to implement this bigger test case, right? So this is how you can simply solve this problem by worrying only about the current node. This is the very important thing about recursion. Don't think about the whole problem. Think only about the current node. What are you going to do with the current node? How are you going to set its answer, and what value is this current node going to return to its parent, right? So this is how you can solve any recursive problem. Now I'm thinking of like if there is anything else that we need to discuss in this particular problem, but I believe everything is covered. Yeah, so there is one more thing. Let's say you had a tree like this, right? So I wanted to discuss this part. Now let's say this is the root node, and this is 1, this is 7, right? After you have received 1 and 7 as the leftmost node and the rightmost node of this particular node, you also need to set up a connection between these two, right? So this is the last step that you need to follow separately apart from your recursive function, and we'll see how I've done it in a while, right? So that was it for this problem. If you have doubts or if you have any queries, you can drop it down in the comments, or you can rewatch this part like again. I've tried to explain it in a very simple manner by breaking it down into smaller steps, and I hope that this part was clear to you. Now moving on to the code solution, I just submitted it. You see that I submitted it just a while before. It's 5:50 and it's 6:66 right now. So basically, let's just see the code. So you see, I've called my helper function on the root, right? So this is going to be the root node, and before that, if the root that is being passed to me is itself null pointer, I'm just going to return null pointer. So let's just see what happens here in this helper function. So if the current node is null pointer, I'm going to return null pointer as a pair, right? Now I receive two values. One is from the left subtree and one is from the right subtree, and I mark them as left result and right result. So what is going to be the left of my current node? It is going to be the rightmost node in my left subtree. So that is left result dot second. And what is going to be my right? It is going to be the leftmost node in my right subtree. So it is going to be right result dot first, right? And if left result dot second exists, that means the greatest node or the rightmost node in my left subtree. So I also have to mark it the other way, right? So I did this here. Current left is equals to left res dot second. I have to do current left res dot second is equals to dot right is equals to current, right? So basically what I'm trying to do is, if I am setting a connection like this, I also have to set a connection like this, right? This is what a W linked list means. So this is just that for the left and the right part similarly. And if I have a few conditions here. So this is a ternary operator. If left result dot first is not null pointer, so I'm just using this particular part. If it is null pointer, it is going to evaluate as false. If it is not null pointer, it is going to evaluate as true. So if it is not null pointer, I'm going to return the value itself. Otherwise, I'm just going to return the current node as the leftmost node. If there is a rightmost node, if it exists, I'm going to return it. Otherwise, I'm going to return current. Right. So yeah. And now when I come back from here, right, I have done all the things, and for the root I have the leftmost node and the rightmost node. So I am just going to set up a connection as the first node's left is going to be the last node and the last node's right is going to be the first node, and then at the end I can just return the first node. So you see, if you think of it in just a single step, then this recursive problem was very easy, right? Otherwise you will like waste much time in just analyzing the problem and thinking about the problem, and you will not be able to gain anything out of it. So that was it for this video, and I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video. I really didn't had to make this video, but I just wanted to share this problem with you all. That is why I am making this video even after being so late. So I hope that you guys were able to appreciate it, and just show some love, because your engagement with this particular video really helps the YouTube algorithm to understand that this video was actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today, and till the next video drops, keep coding, stay safe, bye bye.